Now I started recording again. The last sentence of this slide, you can see my share, right? My screen share. Okay. If you can give me an answer through the chat, I would be appreciated. You can see the 23rd page, right? Okay, thank you, Kevsar. Thank you, Ekran. The last line is applications where data from multiple sources are integrated. Again, three-tier architecture is a fine architecture to use. The only we have discussed and compared thin clients, fat clients, and three-tier architectures from the viewpoint of different system properties such as performance, maintainability, scalability, and security, at least. Okay. Now I will go to the next. This slide concludes our discussion about the client-server architectures. Please, if you have any questions, ask through the chat panel. If necessary, I can also unmute you so that you can direct your question audio. Do you have any questions on the client-server architectures? Okay, then I continue with the distributed object architectures. Well, as opposed to client-server architectures, distributed object architectures, in the distributed object architecture, the different processes don't have any distinction as clients or servers. Okay, each node of a distributed object architecture may serve both as clients and servers. Each distributable entity is an object that provides services to other objects and receives services from other objects. Object communication is through a middleware again, but this time this middleware is called an object request broker. Object request broker. However, distributed object architectures are more complex to design than client-server systems. So they have in distributed object architectures, we have nodes that serve both as servers and receivers and clients, sorry. But the problem is that this distributed object architectures are more complex to design than client-server systems. Okay, a remainder or an announcement in between. I will put this record plus another record that I offline recorded to the UZEM server, so that you can, if you like, copy them and listen to them. In my other recording, I have more detailed information about the distributed object architectures and client-server architecture. So you can also have a look at that recording. But you will have that this recording too in the UZEM server. Okay. Well, this is a typical distributed object architecture diagram. Here we have Here we have six nodes, six processes which serve both as servers and clients. That is, they can provide services and receive services at the same time. And there is this object broker, object request broker in the middle that have all these nodes communicate with each other. Okay, what are the advantages of the distributed architecture? It allows the system designer to delay decisions on where and how services should be provided. It is a very open system architecture that allows new resources to be added to it as required. And the system is flexible and scalable. It is possible to reconfigure the system dynamically with objects migrating across the network as required. Um, well, it is scalable because you may add. It is flexible and scalable. That is, it is fault tolerant and scalable. Distributed object architecture is fault tolerant, scalable, because you may add a node to the system while the system is running. So it is not necessary to somehow stop the system or to somehow pause the system. The nodes can be easily added, and that makes up the flexibility and scalability of the distributed object architecture. Okay. Well, what is the uses of distributed object architecture? As a logical model, allowing to structure and organize the system. In this case, you think about how to provide application functionality only in terms of services and combination of services. As a flexible approach to the implementation of clients. So distributed object architectures you can use to represent or to simulate client and server architecture, because each object you can use either as a server or as a client, or in general, as I said, each object is capable of both providing and requesting services. Okay, this is a typical distributed object architecture. Here we have, at the left-hand side, we have 3 database units. At the right-hand side, we have different output functionality. And in the middle, we have integrator objects, which are used to perform application functionality. That is, since this is a data mining system, integrator objects collect information from different databases at different sites, most probably, and they use this information to come up with the associations or relations of different information. For example, a retail store can find out using this data mining system what products should go with what products. The databases include this information. For example, a diaper and beer and chips are sold together, especially when football games are shown on the television. So integrator objects can find out this information, and they can make the system send information to the report generator or visualizer or some type of display, so that the necessary people, the relevant people know that diapers and beers and chips are sold together, especially on football game days on television, and they sell these products together. Okay, but to do that, you see here there are interfaces which are used to connect, or which are used to provide information, necessary information to the integrator. Integrators get this information from different databases and process the information and send the necessary send the decisions they make to the output generators. Okay, so here, as you see, it is hard to talk about a client and server, because integrators uh, are should be capable of extracting information from different databases, which may be in a position to supply this information using different formats. But these interfaces make these information or convert this information to the format available by the integrator objects, and this is important from the viewpoint that these interfaces are providers of services, and these interfaces are important from the viewpoint that they provide services and receive services at the same time. Okay. Well, the logical model in the data mining system is not one of service provision where there are distinguished data management services. It allows the number of databases that are accessed to be increased without disrupting the system. It allows new types of relationship to be mined by adding new integrator objects. So in this system, you can add another integrator object easily. So that means application functionality or application processing layer is scalable. How is that operated? How is this possible? If the integrator object plays both the role of a client and the server at the same time, then this is easily done, and this system is thus easily scalable. Okay, now we're gonna talk a little about Corba. Corba is a standard object request broker. Please note that, or keep in mind that Corba stands for Common Object Request Broker Architecture. So it is not noted in the lecture notes somewhere. Please note that, or keep in mind, Common Object Request Broker Architecture. So this is a middleware to manage communications between the distributed objects. Uh, it is required for distributed computing at two levels. At the logical communication level, the middleware allows objects on different computers to exchange data and control information. And at the component level, the middleware provides a basis for developing compatible components. So, well, Corba components have been defined by OMG, Object Management Group, and Corba is composed of, okay, it has a somewhat complex structure. It is composed of the object request broker itself, plus, okay, the distributed system is composed of the object request broker, that is Corba, application objects, domain facilities, okay, code or objects that are developed specifically for the domain in which the system runs. Horizontal Corba facilities, I will explain that in a bit, and other Corba services. Okay, domain independent interfaces. Corba services are domain independent interfaces used by distributed object programs. An example is a service providing for the discovery of other available services, almost always necessary regardless of the application domain. The naming service is one, the trading service is another one, and Corba common facilities, the common to many application domain, that is, these which are common to application, these services which are common to many application domains, we call horizontal Corba facilities or horizontally oriented Corba facilities. But unlike object services, they are oriented towards end user applications. Okay. An example to that is distributed document component facility, a compound that is a compound document common facility based on OpenDoc. DDCF, that is distributed document component facility, allows for presentation and interchange of objects based on a document model. For example, facilitating the linking of a spreadsheet object into a report document. What else can I say about this slide? Okay, I guess this is good enough for this slide. All right, there is a, okay, after, well, we have talked about the multiprocessor architectures, we have talked about the client server architectures, and we have talked about the distributed object architectures. Now we have another class of architectural type, inter-organizational distributed computing. Well, before, distributed computing was mostly implemented at the organizational level, that is, within an organization. And this was due to security and interoperability reasons. Okay. This way, in the distributed computing, local standards of the organization can be easily applied. And for web-based systems that are systems which are connected as client computers to the organization's servers from outside, they were running only user interface software. So they were this way easily connected. But now Inter-organizational distributed computing models are also available. And these are peer-to-peer, that is P2P computing systems, and also service-oriented systems. Now let's see how peer-to-peer computing systems and service-oriented systems are organized, are designed. Peer-to-peer systems are decentralized systems where computations, where computations may be carried out by any node in the network. So these are decentralized systems. That means there is they are connected to each other, but there is not a central computer. The overall system is designed to take advantage of the computational power and storage of a large number of networked computers. So there is a network, and through this network, nodes, computer nodes, are connected to each other directly. Most peer-to-peer systems have been personal systems, but there is increasing business use of this technology. So some examples are file sharing systems, instant messaging systems such as ICQ to establish a direct communication between users. Okay. Well, in the P2P or peer-to-peer architectural models, the logical network architecture is decentralized, and this way it is fault tolerant, but there is a big peer communication overhead. So that means between the peers, the redundant, many redundant code runs, and this brings about the communication overhead. Okay. There is also semi-centralized architectures to peer-to-peer architectural model. Some nodes act as servers to facilitate node communications, and this can avoid the disadvantage that is peer communication overhead a little, the semi-centralized ones. And there's also application architectural level of peer-to-peer architectural models. Here, the generic organization of components make up a peer-to-peer application. Well, here you see a decentralized peer-to-peer architecture. As you see, many redundant nodes is there between many redundant nodes are there for each peer-to-peer connection. So in the semi-centralized node, each node is connected to a discovery server. The discovery server gives information to each node about what node is available in the network, so that the redundant connections are avoided to some extent. Once, for example, N6 learns that N3 is on the network and available, then N6 cuts this connection and directly connects to N3, but not beforehand. It only establishes a direct connection with N3 after it has learned that that the N3 is in the network and available. And the service-oriented architectures is another type of inter-organizational architectures. Here, the development of the World Wide Web systems means access is possible of clients to remote servers, provided that servers keep information in HTML. But the problem is HTML-only access is not practical. What, for example, if information is kept other than using HTML? And solution to that problem is the web services. Information providers define and publish a web service interface that defines the data available and how it is accessed. So service provided is this way, service provided becomes independent from the application using the service. So whether or not the information is kept in HTML doesn't make any difference, because the web services handle this problem. A service provider may offer specialized services, and any service user can use it using a standard programming language or a specialized one, which makes the service independent from the HTML. How a web service works is service provider offers a service by defining its interface and implementing its functionality. So it defines its interface and it implements its functionality. Service requester binds that service into its application. So it includes the service in its code, and to call that service and process the results of the service call. So service requester binds this service by including code to call this service, and whatever this service provides is handled in its functionality. And once the service provider does its job, the results are taken by the requester and processed accordingly. Service provider then makes an entry, what the service does and how it is accessed, in a service registry to ensure the access of service by external users. So it provides this service, the service provider provides this service, and it makes sure by an entry that others, I mean the service requesters, know what it does and how it can be accessed. So it is conceptually shown like this. The service provider makes an entry through the service registry, and service requester sees through the service registry what the service it is interested in is given by the service provider, and it directly is bound to the service provider by binding it in its code and taking the necessary results from the service and uses it in its own application. Okay, this is the end of the distributed system architecture. We have still a few minutes. If you like, you can ask your questions after I have stopped recording, or we can finish the lecture. Now I'm stopping the recording.